Math 8, Unit 6, Pythagorean Theorem in Real Numbers, Lesson 8. Multiplying radical expressions. When you multiply radical expressions, you multiply the coefficients together and you multiply the radicands together. So if you have a times the square root of b times c times the square root of d, the outsides, a and c, the coefficients will multiply together, and the radicands, b and d, will multiply together on the inside. A number example, 2 times the square root of 6 multiplied by 3 times the square root of 5. You'll have 2 times 3 on the outside and 6 times 5 on the inside, giving you 6 times the square root of 30. Let's go over some quick examples, because sometimes the example should be so quick it doesn't really take much to do. Right here there's only outsides. 2 times 5 is 10. So this is 10 square roots of 3. Here where there's only insides, there's nothing on the outside, 2 and 3 make 6. It's just the square root of 6. Here where you've got both, the 11 and the 2 on the outside, 11 times 2 is 22, and the 2 and the 7 on the inside, 2 times 7 is 14. You get 22 square roots of 14. And 5 square roots of 3 times the square root of 10. The 5 on the outside has nothing else to multiply by. Well, technically a 1. And on the inside, 3 times 10 is 30. You get 5 square roots of 30. Multiplying radical expressions may include use of the distributive property. Let's find each product. So here we're going to take the square root of 6 and distribute it to both of those. Well, the square root of 6 times the square root of 3 is the square root of 18. Plus 5 times the square root of 2 times 6, which is 12. Now, 18 and 12 can both reduce. 18 is 3 times 6, which is 2 times 3. And 12 is 4 times 3, which is a couple of 2's, giving us the square root of 2 times 3 times 3, plus 5 times the square root of 2 times 2 times 3, which can simplify down. The 3's can reduce and come out. This is 3 square roots of 2. This 2 can come out. It's 2 times 5 square roots of 3, which, by the way, is 10. This is 3 square roots of 2 plus 10 square roots of 3, which will be the final answer because these are not like radicals. We can't combine them together. Example 9. 3 square roots of 3 plus 2 square roots of, or 3 square roots of 3 times, parentheses, 2 square roots of 6 plus 4 square roots of 10. We distribute that in. 3 times 2 is 6. 3 times 6 is 18. 3 times 4 is 12. 3 times 10 is 30. We can reduce 18. We found it earlier. This is 6 times the square root of 2 times 3 times 3. Plus 12 times the square root of 30 reduces into 2 times 15, 3, and 5. 2 times 3 times 5. So I can pull out a 3 here. This is 18 square roots of 2 plus 2, 3, and 5. There's no pairs, so I can remultiply them together. 12 square roots of 30. There's nothing more I can combine together. So the answer there is 18 square roots of 2 plus 12 square roots of 30. More examples. Start by distributing. The square root of 2 times the square root of 8 is the square root of 2 times 8, 16. The square root of 2 times 4 square roots of 3 is 4 square roots of 6. Now 6 is just 2 and 3, so there's no pairs. The square root of 16 is exactly 4, so we are actually done with that one. And we get 4 plus 4 square roots of 6. Number 8, this one's a little bit more complicated. We're going to have to take this entire thing and distribute it first. 4 plus the square root of 5 times 3 plus 4 plus the square root of 5 times the square root of 5. And then we're going to need to distribute again. 4 times 3 is 12. 3 times the square root of 5 is 3 square roots of 5. Square root of 5 times 4 is 4 square roots of 5. And the square root of 5 times the square root of 5 is 5. We've got some like terms here. It looks like the 12 and the 5 can go together to make 17. And 3 square roots of 5 plus 4 square roots of 5 is 7 square roots of 5. So when multiplying these two together, we get 17 plus 7 square roots of 5. I think I'm going to kind of move, well, I think I can shrink it down and move it out of the way. I just need a little bit more room for the next problem. So I need to distribute. Square root of 5 times 2 square roots of 10 is 2 square roots of 50. I don't know why, but that often comes out looking like an 80. 2 square roots of 50 plus 3, and then 5 times 2 is 10. Now 50 is 5 times 10, 2 times 5. So this is 2 times the square root of 2 times 5 times 5. We'll go ahead and pull a 5 out. And 10 is just 2 times 5. There's no pairs. So this is 10 square roots of 2 plus 3 square roots of 10. And we can't go any further than that. That is simplified down all the way. Let's go over a couple of situation problems, or word problems. Determine the area and perimeter of the triangle. Express answers as simplified radical expressions. Well, the first thing we'll need to do on this one is find the length of this side, which we can use the Pythagorean theorem to do so. It looks like if we call this a, this will be a squared plus the square root of 60 squared equals the square root of 96 squared. This is a squared plus 60 equals 96. We can subtract the 60. A squared equals 36, and lucky for us, that is a perfect square. So this side length is 6. And I'm going to go ahead and shrink out that information. We did find that it is 6, and now we can pardon me for that interruption. And now we can find the perimeter. Before we go through that, let's go ahead and simplify these down. 60 is 6 times 10. This is 2, 3, 2, and 5. So this is the square root of 2 times 2 times 3 times 5. The 2's can come out. We get 2 square roots of 15. 96. 96 is 16 times 6. 16 is 4 and 4. Each one's 2 and 2. The 6 is 2 and 3. So this is 5 2's and a 3, which gives us 2 times 2 times the square root of 6, 4 square roots of 6. Okay, I'm going to get rid of a bunch of this and say this is the same as 4 square roots of 6, and this one over here is 2 square roots of 15. So the perimeter is going to be 6 plus 4 square roots of 6 plus 2 square roots of 15. There are no numbers that can simplify down there. So that's it. 6 plus 4 square roots of 6 plus 2 square roots of 15. The area is 1/2 base times height. The base are going to be the 2 legs. 6 times the square root of 60, which is 2 square roots of 15. 1/2 times 6 times 2 is 6. So the area comes out to be 6 square roots of 15 square units. And the perimeter was 6 plus 4 square roots of 6 plus 2 square roots of 15. Okay, determine the area and perimeter of this rectangle. Express answer as simplified radical expression. Okay, the perimeter is going to be 2 square roots of 6, giving you both sides here, plus 10 plus 2 square roots of 3, giving you 5 plus the square root of 3 twice. Now this doesn't have anything that can reduce, so that is the perimeter. The area, be a little more interesting. It's going to be the square root of 6 multiplied by 5 plus the square root of 3. There are some things that we can simplify down here. We will distribute. We get 5 square roots of 6 plus the square root of 18. Keep in mind that 18 is 3 times 6. 6 is 2 times 3. So the square root of 18 is 2 times 3 times 3. Pull out the 3's, 3 square roots of 2. So this is 5 square roots of 6 plus 3 square roots of 2 square units. And that is the area. Determine the area and perimeter of this rectangle. Answer as a simplified radical expression. Ooh, this one's nice. It's actually easier if we simplify this down first. This is 12 times 10. This is 2 times 5, 4 times 3, 2 times 2. So that's 1, 2, 3, 3 2's, a 3 and a 5. That gives us 2 square roots of 2 times 3 times 5 is 30. So that is the square root of 30, or 2 square roots of 30, plus the square root of 30. This ends up being 3 square roots of 30 for that side of the rectangle. And simplifying the other one, 50 is 5 times 10, 5 times 2. So 2 times 5 times 5. The 5 can come out, leaving a 2 inside. So this is 5 square roots of 2. The 112 is 2 times, what would that be, 56? 56 is 2 times 28. This is 2 times 14, 2 times 7. That goes down quite a ways. 4 2's and a 7. 2 times 2 times 2 times 2 times 7. We can take out a couple of 2's, and we're left with a 7 inside. So that is 4 times the square root of 7. All right, so go ahead and clean this up a little bit. We have, for our perimeter, we're going to have 2 of each of these. So 3 square roots of 30 becomes 6 square roots of 30 when we have 2 of them. 5 square roots of 2 becomes 10 square roots of 2. And 4 square roots of 7 become 8 square roots of 7 when we include both sides. And that is the perimeter. Nothing reduces. The area is just length times width. We're going to take the square root of 30, 3 square roots of 30, and multiply it by 5 square roots of 2 plus 4 square roots of 7. We distribute this, and we get 15 square roots of 60 plus 12 square roots of 210. 7 times 30. Now 60 is 6 times 10, 2 times 3, 2 times 5, 2 times 2 times 3 times 5. We can actually pull out a 2. So the 2 that we pull out goes with the 15 that's there, and left inside is the 3 times 5, 15. Now 210 is 21 times 10. 21 is 3 times 7, and 2 times 5 is the 10. 2 times 3 times 5 times 7. There are no pairs of factors, so that one doesn't break down. So this is the area. 30 square roots of 15 plus 12 square roots of 210 square units. All right, I'm going to skip over that, and let's get right into the previewing the practice. On number 1, you're going to be simplifying some square roots where you have to do some distributing. Number 2, I want you to get an irrational approximation for these and then match them up with one of the points plotted on the number lines. I think there's a test question like that. Number 3, find the function that goes through those 2 points. Number 4 is review from Unit 3. You need to find the values of x and y because those are, is that parallel? It doesn't say it's parallel. Oh yeah, it does. EF is parallel to AB. ABC is an isosceles triangle. You can find the measure of x and the measure of y from that information. Okay. Number 5 is determining the slope. Number 6, this goes back to Unit 1, solving an absolute value equation. Number 7 introduces the Pythagorean theorem as a function, and you're to evaluate each of those function values with 2 inputs. And then number 8, you get to pick one of these, and whichever one you pick, you need to find the area and the perimeter of the one you picked. This will be similar to the examples that were in the video.